Okay, today we will be solving right triangles using the trig functions from yesterday, sine, cosine, and tangent. And inside this little text box, we have our two special right triangles you learned back in geometry. And you have these formulas that the side opposite of the 30-degree angle is x, the hypotenuse would be 2 times x, and the side opposite of the 60-degree angle is x square root of 3. So let's say that the side opposite of the 30-degree angle were 2. Then what would be the value for the other leg? 2 square root of 3, and what would the hypotenuse be? Yeah, 2 times 2 would be 4. So there's the 30, 60, 90 triangle. Now, if you know those values, it'll save you a little bit of time today. Same thing with the 45, 45, 90. If you know this formula or the sign, then it will help you save some time. Now notice that the side opposite of the 45-degree angles are labeled x. The hypotenuse is x square root of 2. So if I use the same example, let's say that x is 2, then what would the hypotenuse have to be? 2 square root of 2. So that's how you apply this formula. Now, solving some triangles. Problem number 1, it says use a right triangle to solve for x. So if you have to use a right triangle, draw yourself one. So drawing my right triangle, they're using A, B, and C. And we're going to note that C is going to be the 90-degree angle. So this is triangle A, B, and C is the 90-degree angle. Now, what I need to do next with my triangle is fill in everything they gave us. So they told us that angle B is 65 degrees. They said that side C is 2, and they said side A is x, and we need to solve for x. So we're going to solve for x using one of our trig functions from yesterday, or trig identities from yesterday. So notice we're given the 65-degree angle, and we have the adjacent side and the hypotenuse. So what trig identity should we use? Cosine. So this would be cosine of 65 degrees. And how do you find cosine? Adjacent, which would be x, over hypotenuse, and the hypotenuse is 2. Now solve for x. If x is being divided by 2, the opposite would be multiply both sides by 2. So make sure you're in degree mode. And in your calculator, you need to do 2 times cosine of 65 degrees. Now make sure your calculator is in degree mode. And if it's in degree mode, all you have to type in would be 2 times cosine. And when it opens up the parentheses, all you need is 65. You don't have to put the degree symbol because your calculator understands that it's in degrees because you're in degree mode. So you don't have to do second out number 1 for the degree symbol. And we are going to round sides to the nearest tenth today. So what would be that side length to the nearest tenth? 0.8. So 0.8 seems small, but it seems legitimate because if the hypotenuse is 2, I know that both legs have to be smaller than 2. So that seems legitimate. So 0.8 is our answer to the nearest 10th. Next one, now it says solve each triangle. When it says to solve a triangle, you need 6 answers. You need 3 answers for all of the angles, and you need 3 answers for all of the sides. And notice we have angle A, B, and C. So just like yesterday, we're using capital letters to represent our angles. And we're using lowercase letters to represent the side length. So again, capital letters are for the angles, and lowercase letters are for the side length. Now, when I list my answers on the key, it will be just like this. The angles will be listed first, and then the sides, and I typically write them in alphabetical order, so A, B, C. Now, let's go ahead and fill in what they gave us. They told us that for angle A, it's 36 degrees. Angle C is marked as a 90-degree angle. And if you know two angles in a triangle, you should automatically know the third one, because all three angles should add up to how many degrees?
180.
180. So if we already have 90 degrees here, then A and B also have to add up to 90. So if you do 90 degrees minus 36 degrees,
54.
that would be 54 degrees for angle B. So we have all three angles. Now we need three more answers. This 5, is that for side A, B, or C?
B.
Yeah, it's the side opposite of angle B. So for side B, we'll put a 5. Now we have to solve for the other two sides, and we'll solve for the other remaining sides using some of these trig identities. So let's see. Let's solve for side A. With all the information I have labeled on this triangle, we're using the 36-degree angle. What trig function would I have to use if I know the opposite side and the adjacent side? Tangent. So this would be tangent of 36 degrees equals, and to calculate the tangent is opposite over adjacent. So A over 5. And solve for A, so A is being divided by 5. Next step would be multiply both sides by 5. So in the calculator, you need to do 5 times the tangent of 36 degrees. If you're in degree mode, you don't have to type in that degree symbol. Just 5 times tangent of 36. And our side lengths, we're going to round to the nearest 10. I didn't finish reading all the directions. It says round sides to the nearest 10 and angles to match. So that means here, if they rounded their angles to the nearest whole degree, then my answers need to be to the nearest whole degree, unless it's otherwise stated. So what would side A be to the nearest 10? 3.6? So A is 3.6. Now we need to find side C. So side C is right here. So I'm using what's on that triangle, because I don't want to use this answer of 3.6. Why do I not want to use 3.6 and do boundaries here? 3.6 is rounded. Do I want to use a rounded answer to try to find another answer? No, I want it to be as accurate as possible. So don't use anything that's been rounded, unless you have to. But here, we don't have to. We can do other things. So looking at what's on the triangle, what would we have to use to solve for side C? Would we have to use sine, cosine, or tangent? Yes, we have the adjacent side and the hypotenuse, so we would have to use cosine. Let me switch to blue. This would be cosine of 36 degrees equals 5 for the adjacent side and C for the hypotenuse. Now, if I turn this into a proportion, I can cross multiply. So this would be C times the cosine of 36 degrees, and set equal to the other cross product, and 1 times 5 is 5. And if C is being multiplied by the cosine of 36 degrees, what would the opposite be? Divide both sides by the cosine of 36 degrees. And our side length, we're going to round to the nearest 10. So in your calculator, you need to do 5 divided by cosine of 36. 6.2? Sounds like we agree on that. So for side C, it's 6.2. So when you're solving these triangles, make sure you have answers for all three angles and all three sides, including the given information. Next one. Now this one says that we need to round our angles to the nearest degree. So again, we're not using A, B, and C this time. We're using G, H, and J. So I'm going to write my answers alphabetically. So these three capital letters represent the angle, and over here to the side, the lowercase letters represent the side length. Now, the only angle they gave us was angle H, which is 90 degrees. And the 6 is for which side length? J. And the 8 is for which side length?
G.
G. Now, if you know your Pythagorean triple, that would be helpful. This one's actually a triple. Which one is it?
6,
6, 8, 10. This is a 3, 4, 5. That's the number 7 double. So this is a 3, 4, 5. So this is 6, 8. So side H is 10. Now, if you did not recognize that it was a 3, 4, 5 triangle, what would you have to do to find that missing side? Yeah, the Pythagorean theorem. A squared plus b squared equals c squared. Okay, now we need to find those missing angles. So let's start by finding angle G. So since we have all three sides, we could do all of the functions. We could do sine of G, we could do cosine of G, we could do tangent of G. Which one do you want to do? Sine? So this would be sine of G. We don't know what G is. We're solving for that angle. And we're doing sine. Sine is opposite over hypotenuse. So what is the opposite side? 8. And what is the hypotenuse? 10. Now notice this is the answer. Remember from yesterday, this is called the arc sine. And if you have the arc sine, how do you find the missing angle? You do second sine. And when you do second sine, your calculator will show the sine to the -1. So do second sine of 8 divided by 10. And then close the parentheses. Now, if you're not sure how to round, notice up here at the very top how they say to round our angles. To the nearest whole degree. So what would that answer be to the nearest whole degree?
53.
53 degrees? Do we agree? 53 degrees. So G is 53 degrees. And G and J have to add up to 90 degrees. So what is 90 degrees minus 53 degrees? 37 degrees. Okay, so we're finished with that triangle. We have all three angles, all three sides. Next one, now we have B, C, and F. So we need angle B, angle E, angle F. And we need sides D, E, and F. Now I'm going to go ahead and fill in everything they gave us. So angle E is 90 degrees. Angle F is 28 degrees, 42 minutes. And side F is 4.5. So those are the three values given to us. Now we just have to solve for 3 more. Now in the instructions it said for the angles to round to match, or not round to match, but make sure your angles match. So what they mean by that is notice right here, we're given degrees and minutes. So my answers for the other angles need to also be in degrees and minutes. So don't use decimals, make sure that you match whatever you're given. So if they use degrees and minutes, your answer for the angles also needs to be in degrees and minutes. So we can find that third missing angle because we know that angle D and angle F have to add up to how many degrees? These two right here add up to 90 degrees. So if I take 90 degrees and subtract 28 degrees, 42 minutes. Technically, you have a calculator, you can do that in a calculator. But what if you don't? What if you froze up? What if you didn't realize that? Well, do I have anything to subtract the 42 minutes from? No. So I'm going to have to borrow from the 90. I'll drop this down a degree. So I'm borrowing a degree. Well, how many minutes are in 1 degree? 60 minutes. If I borrow 1 degree, that is equal to 60 minutes. Now I have something to subtract from. So what's 60 minus 42? 18 minutes. Now for the degrees. 9 minus 8 is 1, and 8 minus 2 is 6. So that missing angle is 61 degrees, 18 minutes. Now, let's find side D next. So here's D right here. Using what's labeled on that triangle, what trig function will we have to use? Sine, cosine, or tangent?
Tangent.
Yes, we have the opposite side and the adjacent side, so we will have to use tangent here. So we need to do tangent of 28 degrees, 42 minutes, and tangent is equal to opposite, which is 4.5, over adjacent, which is B. And if I change this to a proportion and multiply this diagonal, this would be D times the tangent of 28 degrees, 42 minutes, is equal to 4.5. And the opposite of multiplying would be divide. So we need to divide both sides by tangent of 28 degrees, 42 minutes. Now, in the instructions prior to this, it says to round side length to the nearest tenth. So remember to do the degree symbol, it's second at number 1. To do the minute symbol, it's second at number 2. And what would that be? 0.2? 8.2. 8.2. We agree with 8.2? So D is 8.2. Okay, now we need to find side E, and we're not going to use Pythagorean theorem because this 8.2 is a rounded answer, so I don't want to add more inaccuracy to my answer. So let me erase this so we can still see what's on the screen. And now we need to find side E. So here is side E. So looking at what's labeled on that triangle, what trig function would I have to use? Sine, because we have the opposite side and the hypotenuse. So this would be sine of 28 degrees, 42 minutes, equals opposite over hypotenuse. So 4.5 over E. And again, if I make this into a proportion, this would be E times the sine of 28 degrees, 42 minutes, is equal to 4.5. And what would be the last step? Divide both sides by the sine of 28 degrees, 42 minutes. And what do we get? We agree with 9.4? Next example. This one. We have to find M, N, and P. Fill in what they gave us. So I know that side M is 4. Side N is 4 square root of 2. And angle N is 90 degrees. Who wants to do a bunch of unnecessary work? You want to do a bunch of unnecessary work? What do you notice?
The 45, 45, 90.
Yes, this is a 45, 45, 90. So do I have to do all that church stuff? Absolutely not. So I know that because of this 4 and the 4 square root of 2, that means these sides are equal. So this leg is 4, this leg is also 4. And if this is 90 degrees, then both M and P, those angles are both 45 degrees. So if you know those special right triangles, it'll save you a little bit of time. We didn't have to do any of that trick stuff. And if it's a 30, 60, 90, same thing. If you just recognize it, you don't have to show any work. You can just say it's a 30, 60, 90 triangle and move on with your day. Okay, these next questions are all word problems, and these will go a little bit more quickly because instead of finding 6 answers, we only have to find 1 answer. Now, most of these word problems use the terms of angle of depression or angle of elevation. Now, what you need to know about both of these angles are going to be measured from a horizontal line. So we have depression and we have elevation. Think about your mood. If your mood is depressed, is your mood up or is it down? Down. So an angle of depression is the angle that comes down from your horizontal line. So the angle of depression, here's the horizontal line it's being measured from. And if it's an angle of depression, it's the angle that comes down from the horizontal line. Now for an angle of elevation, think about your mood. If your mood is elevated, is it up or is it down? It's up. So if you're talking about an angle of elevation, here is the horizontal line we're measuring from. But if it's an angle of elevation, it's the angle that comes up from the horizontal line. So the big thing here is make sure you recognize that both of these angles have to be measured from a horizontal line. Okay, so let the fun continue. Number 6. A 98-foot extension ladder rests on top of a hook and ladder truck with its base 11 feet from the ground. When the angle of elevation of the ladder is 73 degrees, how high up the building will it reach? Now, these word problems are best solved by drawing yourself a diagram. Now, if you're an artist like me, yours will look gorgeous. So we're talking about a hook and ladder truck. And I'm a boy mom, so I know when they're talking about a hook and ladder truck, what are they actually talking about?
Fire truck.
Fire truck, yeah, that's a fire truck. If you couldn't tell from my masterpiece over here. Yeah, fire trucks are red typically. What is that thing on top? It's the hook that the ladder is attached to. There's my fire truck. Needs some nice wheels. Yeah, I do art teaching in my free time. Okay, so there's my fire truck, and it's going to be propped up against a building. Let's see what they told us. So we have a 98-foot extension ladder. So I know that this ladder is 98 feet long. And it says its base is 11 feet from the ground. So that means the base of the ladder from here to here is 11. So really what I need to do is make myself a little right triangle right here. And the distance from the ground to where the ladder is 11 feet. Let's see what else I can fill in. It says that there's an angle of elevation of the ladder is 73 degrees. So there's what we were just talking about, angle of elevation. So angle of elevation is that the angle that comes up from the horizontal line or the angle that comes down from the horizontal line? Up. So here's my horizontal line. So my angle of elevation is the angle that comes up from that horizontal line. And that angle is 73 degrees. And they want to know how high up the building will it reach. So here, we need to solve for x, but is this actually what they're asking us for? No. No, they want to know how high up the building it goes. So it actually wants to know this entire section. So once we solve for x, what do we have to do with our answer for x? Add 11 feet to it. So looking at my right triangle, What trig identity would we have to use? Sine, cosine, or tangent? Sine. We have the opposite side and the hypotenuse. So this would be sine of 73 degrees is equal to the opposite side is x and the hypotenuse is 98. So the opposite is divided by 98. Multiply both sides by 98. And 98 times the sine of 73 degrees.
93.7.
We're going to round to the nearest tenth. So all sides to the nearest tenth. So you said 93.7?
Yes.
We agree?
Yes.
Yes? But that is just this piece right here. So once I have the 93.7, what do I need to do to that? Add that base length. And so what would our answer be? 104.7 feet. Don't forget your units. So 104.7 feet. Okay, our diagram drawing continues. Let's see how much skills increase. Number 7. The altimeter of a jet approaching O'Hare Airport in Chicago reads 5,900 feet as it passes directly over the Sears Tower. At the same time, the angle of depression from the plane to the end of the runway is 5 degrees. How far is it from the base of the Sears Tower to the end of the runway? So here comes my drawing. Here is my Sears Tower. It's quite impressive. Lots of people come to visit and look at it. And we have a jet that is passing directly over my tower. So I need to draw myself a jet plane. There's my jet plane. Kind of this bird-like stuff. Okay, there's my jet plane. And that jet plane is approaching this runway. And then they said something about an angle of depression. It says the angle of depression from the plane to the end of the runway. So I need to draw a line that goes from the plane to the end of the runway. And what shape have I actually made? A right triangle. So here's my right triangle in here. Now I need to fill in the values that they gave me. And let's see, the altimeter, that measures your altitude. And what is altitude?
Height.
The height. So the height of the plane, how many feet up in the air is it? 5,900. So the altitude of the plane is 5,900. And they told us the angle of depression from the plane to the end of the runway is 5 degrees. So if you're talking about an angle of depression, you measure from the horizontal line, and does the angle go up or down? Down. Well, do I have a horizontal line up here at the plane? No. So I'm just going to draw in my horizontal line. And the angle of depression would be this angle right here that comes down from the horizontal line. And how many degrees did they say that angle of depression would be? 5 degrees. Now, if you know that angle, you also know this angle, right? Why is this one also 5 degrees? These two lines are parallel. They're being cut by a transversal. And these are called alternate interior angles, right? And we know that alternate interior angles of parallel lines are what? Congruent. Some of those postulates are coming back from geometry, right? Yep. Now, what do they want us to solve? We want to know how far is it from the base of the Sears Tower, so here's the base of the Sears Tower over here, and to the end of the runway. So what is the distance from here to here? So I'm going to call that distance x. So to solve for x, will we have to use sine, cosine, or tangent? Tangent, because we have the opposite side as well as the adjacent side. So tangent of 5 degrees is equal to opposite side is 5,900, adjacent side is x. And again, you can change this to a proportion or just multiply both sides by x if it's the same thing. So this would be x times the tangent of 5 is equal to 5,900, and that's 5 degrees. And the opposite of multiplying by tangent of 5 degrees, divide both sides by tangent of 5 degrees. And a side length is going to be rounded to the nearest tenth. So what would that side length be to the nearest tenth?
67,437.
We agree with that value, 67,437.3?
Yes.
Yes. Now we need units. And what are the units for this problem? Feet. So make sure you include the units with your answer. Okay, next problem. A passenger in a helicopter shines a light on a car straight at 45 feet from a point just below the helicopter. As the helicopter is hovering at 85 feet, what is the angle of depression from the light source? Okay. The artisticness continues. That's my helicopter. And it's hovering over the ground. And let's see, there's an angle of depression from the light source, and the light source is being shined on a car that's straight at 45 feet from a point directly below the helicopter. So down here I have a car. I guess this car is actually an El Camino. Oh, let's see. So here's my passenger helicopter, and they're shining their light on the car. So somebody in this helicopter is shining their light on this car. So there's the light shining down. And here, what would this be called? We're talking about a point directly below the helicopter. So now I have a right triangle. Now label the values that they gave us in the problem. And it says that the car straight is 45 feet from a point just below the helicopter. So here's the point just below the helicopter, and that car is 45 feet from it. And then they tell us that the helicopter is hovering 85 feet above ground. So this distance would be 85 feet. And we want to know, what is the angle of depression? Now, angle of depression, is that the angle coming up from the horizontal line or the angle coming down from the horizontal line? Down. So I need a horizontal line on my light source. So the angle that comes down, let's talk about this angle right here. Now, when it comes to PRECAL in calculus, if we have an unknown angle, we call it theta. So that's the angle that we're solving for, is theta. So what do I know about theta and this angle down here? They're the same because they're alternate interior angles. So to solve for theta, what trig identity should we use? Sine, cosine, or tangent? Tangent. So this would be tangent of theta equals opposite over adjacent. So what would we put for opposite over adjacent? 85 over 45. Now, what is this fraction called? Arctan. So if you're given the arctan value, make sure in the calculator you do second tangent. So we need to do inverse of tangent. So second tangent, and inside the parentheses, you need to do 85 divided by 45, close that parenthesis. So second tangent of 85 divided by 45. And we'll round the angle to the nearest degree. So what would theta be to the nearest degree? 62 degrees. Sounds like we agree. Next one. Number 9, it says that the Great Pyramid of Cheops in Egypt has a square base, which is 230 meters on each side. The bases of the pyramid make an angle of 51.8 degrees with a horizontal, and here's the angle it's referring to. And part A, we want to know how tall is the pyramid. No, how tall is it? If I want to know how tall. Oh, I need one more piece. They did give us another value. They said that the length of the square base is 230 meters. So from here to here is 230. So what would this distance have to be? Half of that, which would be 115. Now, looking at what's labeled on that triangle, would we have to use sine, cosine, or tangent? Tangent. So we need to do tangent of 51.8 degrees. And we need opposite over adjacent. So what would we put for opposite over adjacent?
X over 1.
X over 115. The opposite of divide by 115 would be multiply both sides by 115. And again, sides will be rounded to the nearest tenth. So to the nearest tenth, let me know what you get.
146.
146.1 meters. Don't forget those units. So 146.1 meters. Now part B. Part B asks of us, what is the shortest distance you would have to climb up a face to reach the top? What are they asking us for? Yes, the shortest distance from the base to the top would be the hypotenuse. I'm going to call that y. So to solve for y, what trig identity would you have to use? We have the adjacent and the hypotenuse. I want you to go ahead and do part B. Okay, solving this one. Looking at the given angle, we have the adjacent side and the hypotenuse, so we'll have to use cosine. So cosine of 51.8 degrees is equal to adjacent, which is 115, over hypotenuse, which I labeled as y. And if you change it to a proportion, you can cross multiply. So this would be y times the cosine of 51.8 degrees is equal to 115. Divide both sides by cosine of 51.8 degrees. And what is y to the nearest 10? 186.0. 186.0?
Yep.
We do? And the units would be meters. So 186 meters. Last one. Number 10, it says a building is 16.3 meters from a television tower. The angle of elevation to the top of the tower is 23.8 degrees. Find the height of the tower. So let's see. Here's my tower. And we have a building that's 16.3 meters away from it. The distance from the television tower to the building, they said is 16.3 meters. What else did they tell us? The angle of elevation to the top of the tower. So the angle of elevation, would that be measured from, would it be coming up from the horizontal line or coming down from the horizontal line? Up. So we need to start at the horizontal line and go up to that television tower. So the angle of elevation would be this angle right here. They said that angle of elevation to the top of the tower is 23.8 degrees. So 23.8 degrees. And we want to find the height of the tower. I want you to solve for x. Find the height of that tower. We'll round to the nearest 10. So sides to the nearest 10. Looking at what's labeled on our triangle, would we have to use sine, cosine, or tangent? Tangent, we have the opposite side and the adjacent side. So this would be tangent of 23.8 degrees equals opposite over adjacent. And the opposite of dividing by 16.3 would be multiplying both sides by 16.3. So what is 16.3 times the tangent of 23.8 degrees to the nearest 10?
7.2.
7.2, and the units are?
Meters.
Meters.